Well, good afternoon, ladies and gentlemen. It's Elwood Shapansky again. It's Tuesday afternoon, and I've been worrying about this presentation. I want to talk about transformers, but to talk about transformers, I have to talk about alternating current. And we've talked a little bit about that, but not enough really to understand what I'm trying to present. This is a more sophisticated set of concepts. It's a little bit more abstract, and I hope that it becomes clear to you. If you will recall, I talked about a motor earlier, and by sending an electric current through the armature on this, the motor will turn, okay? If it is in a magnetic field, it will be a motor. Now, if there's no electricity connected to this and I manually turn this coil, then it will send out a voltage, and that voltage will be alternating. So a motor and a generator can do the same thing. If we put current into it, it's a motor. If we put mechanical energy or do work on it, it is a generator. And in particular, this would be an AC generator. Now, when I was a kid, we would have telephones that would generate the voltage and current necessary to call to another place on the line. These telephones had a built-in AC generator. It's actually called a magneto because these are magnets, and the magnets provide the magnetic field for the coil that is turning inside. And when we wanted to make a phone call, we would turn this crank, and by turning the crank, we would be sending out a AC voltage to somebody down on the same line that we were connected to. Now I have one of these that will work. The magneto is inside this box. If I turn the crank, that's what you would hear if you were on the line. But you'll notice there's a little hammer moving back and forth here because the voltage is moving back and forth. This is an AC generator or a magneto that is generating an alternating current. This is an alternator out of an automobile that generates an AC signal, and then you have to convert it to DC to charge a battery. Okay, so this is a lot of different ideas here, and what I want to talk about is how does a transformer work? Because when Nikola Tesla was working for Edison, they had a controversy about how to send energy through electrical wires a long way. Edison wanted to use batteries. Tesla wanted to use AC generators because there's a very distinct advantage to the AC generators that Tesla knew and understood, and maybe Edison didn't understand so well. Okay, so what we want to do is understand what a transformer is and how it works and why it's important. Now, you don't see transformers very much anymore because everything is miniaturized. But this is a transformer that is used to step down the voltage from 110 volts. Here's a 110 volt plug. You can step it down to 6 volts. It's called a filament transformer, and it was used to heat the tubes in television sets or things like that. So that's what a transformer looks like, but you'll probably never see one because everything has been miniaturized in our lifetime. What you will probably see is only this thing called a charger that is used to charge your iPhone or your iPad. Now, inside this charger is a transformer because something has to step the voltage down from 110 volts down to about 7 or 8 volts. So the transformer steps the voltage down. There has to be a diode in here as well that only lets the current flow in one direction so that it can charge the battery. And there's probably a little tiny thing called a capacitor that is kind of a bucket for charge that stores up and keeps the current from pulsing too much. At any rate, inside your iPhone charger is a transformer, and it's a marvelous thing because it allows us to change the voltage that comes into our house higher or lower depending upon what we want. It also allows us to send energy huge distances along wires without heating up the wires. And that's the big difference. Edison wanted to use batteries, and it would have taken wires a half an inch to an inch in diameter made out of copper to take the energy from a battery and send it to the various houses on a street. Whereas with a transformer, if you go outside and look on the power lines, you'll see round things about the size of a 5-gallon bucket with wires coming out of them. Those are transformers. And they're transforming high voltage in the wires down to a lower voltage that you can use in your house. And you can move that voltage up or down depending upon what you want. So how does a transformer work? We're not going to talk so much about where we get AC, but we're going to talk about how does a transformer work. Well, inside this transformer is something that I've made it up simple out of stuff in my shop. It's a iron core with 2 windings. One is the primary and one is the secondary. If we put an AC signal in here, we'll get an AC signal out here. If they're the same number of windings, then we'll get the same voltage in and out. But if we put 1,000 windings here and 100 there, we'll get 10 times more voltage here. So the ratio of the windings determines the output voltage. So we can either step the voltage up or we can step the voltage down depending upon what we want. Okay, so let's see how this thing works. Well, if you remember, I did a demonstration where a current moving through a wire would experience a force. If I tap this wire to this battery so the current flows through here, the electrons moving in the wire will experience a force and try to jump away from the magnetic field. Watch this. There it is. Okay, so there's 2 ways we can think of this. We can think of the magnetic field interacting directly with the electrons, or maybe a better way to think of it is to say as soon as a current flows through this wire, it generates its own magnetic field. We've already decided that. If we use a compass around here or something to detect the magnetic field, we will note that when there is a current flowing, there's a magnetic field. We know that north poles attract south poles, and here north poles attract the south poles and like poles repel. So if I turn this around, they click together. If I turn them 180 degrees, I can't push them together because the like poles are repelling and the unlike poles are attracting. Okay, we can either say the poles are pushing and pulling on each other, or we can say the magnetic fields are interacting in such a way so as to attract or repel. So there's kind of 2 ways to look at that, and now I want to kind of use those 2 ideas to talk about how this works. The first thing I want you to remember is that if I want a larger magnetic field, I have to make a coil so that I have many wires here, and each coil adds to the magnetic field of the other so that we have a large magnetic field inside the core. Also, iron is a magnetic material. The atoms in the iron will align with the external field, making the field very, very much stronger. So what I have in my hand here is an electromagnet. If I send a current through this wire, it will create a magnetic field inside the wire. It'll magnetize the iron, and this will in fact be an electromagnet, and I can use it to pick up these nails. just like I'm doing right here. Okay, the problem I have today is that this battery provides so much current that I actually have burned up some of my connecting wires. So I can only tap the terminals for a short period of time, because in fact it is a short circuit through these wires. I can only tap it to just demonstrate what I'm doing. So I'm going to hook this wire to this terminal. I'll take another wire, that one I've kind of ruined, and I'll connect it here. And when I complete the circuit, you will notice that the nails will be picked up by the electromagnet. I'm also going to have too much current flowing, but I'll do it real quickly. Okay, now I burned up my wires, but you can see that I also picked up the nails. So this is an electromagnet. I used to use an old weak battery, and unfortunately it died. So now I'm using a stronger battery, and it's causing me some troubles, okay? Now, the interesting idea that we need to understand is that if I have two sets of wires on this iron core, then when I send a current through here, I will set up a magnetic field inside the core. The magnetic field will be inside the iron, and it will pass through the core of the secondary set of windings. So once the magnetic field builds up in here, while it's building up, a voltage is being generated here. Okay? So this is important. The original scientists that studied this said, well, if an electric current creates a magnetic field, why doesn't a magnetic field create an electric current? And they tried and tried to do that until somebody discovered when you make the current or break the current, when the magnetic field is changing inside the iron, or when the current is changing inside the primary, it's only when the change is taking place that the voltage is being generated. And that's why an AC generator is so incredibly expensive, and not expensive, but important. So inside this transformer is something that behaves like this. I made it look simple so that you can see it and hopefully understand it. This is the primary. When we magnetize the rod, we put the magnetic field through the secondary coil. A voltage is generated on the secondary coil that is either higher or lower than the primary, depending upon the ratio of the number of windings. Okay, that's all I can do for right now. This was a hard demonstration to make clear and make sense. I hope you can understand it. I'll probably do another one where I add on to this idea of the changing magnetic field creating the voltage that we can use in a transformer. Remember, the electric field doesn't change, the magnetic field around a wire does not change when the current is direct, but it gets bigger and smaller, goes back and forth with AC, and it's the changing magnetic field that we need to make a transformer work. This very fact has revolutionized, or maybe is even the cause of the Industrial Revolution, because we could now have power generated at a waterfalls. The power could be sent at a very high voltage to a city. A transformer could step the voltage down so that it's safe, and it could be used to run motors, lights, and businesses. Thank you very much for watching. I hope someday to get some feedback on this to see whether I'm making sense. Thank you.